And what we're going to do first is try and find a method to solve the quadratic equations that have the coefficient of their squared term as 1. So you can see your squared term here has the coefficient of 1. If you don't have a number, it's understood that the coefficient term is 1. Now what we want to try and do here is basically take this equation, and we want to try and write this equation in the form of x plus b squared equals k. And the reason we want to try and write it in this form is so that we can apply the square root property and solve this equation. So what we need to do here is we need to take our original equation and write it in terms of a perfect square trinomial. Now a perfect square trinomial is something of this form. Let's say we have a perfect square trinomial that is x squared plus 4x plus 4. Now the idea is if I could take this original equation x squared plus 4x minus 2 and write it in the form of x squared plus 4x plus 4, the reason I want to do that is because this expression here can be factored into x plus 2 quantity squared. So you see what happens when you take an equation and write it as a perfect square trinomial. You can go ahead and factor it in this form, x plus 2 quantity squared, and that is what we want, because then you can end up with something of this form, x plus b quantity squared equals k, and then apply the square root property to try and solve this. So you can see here that your x term, the middle term here, has a coefficient of 4, and your constant term also is 4. So the idea is if we take this 4 here, okay, the one on the x term, you take that 4 and you half it, which means you divide it by 2, and then you square this whole thing, okay? So I took the middle term, 4, I divide that by 2 and I square it. I end up with 2 squared, which gives me 4. Okay, so you will see that you have the same 4x term on the original, and you have the same 4x term in the perfect square trinomial, but the difference is instead of negative 2 now, we have a plus 4, and that's how we were able to factor it. So we are going to try and apply this idea of where we take the coefficient of x, or the middle term, divided by 2, and then square it, and the constant term that you get, that is what will help us into making a perfect square trinomial. So to try and understand this better, let's go ahead and look at an example here. Let's say we have this expression, m squared plus 6m plus 9. Okay, you can try and factor this term and see if you're able to come up with some value. Okay, and of course you will see that this guy will factor into m plus 3 quantity squared. Why does that happen? Let's look at this. You have your middle term, 6. If I half it, which is divided by 2, and then square it, let's see what we end up with. 6 divided by 2 is 3. When you square your 3, you end up with 9, which is what our constant term was, and that's why we were able to factor this out into m plus 3 squared. Let's look at another example. You have t squared plus 12t plus 36. Okay, again, let's go ahead and take a look at this. You take your middle term, 12, half it, and then square it, and you end up with 12 divided by 2 is 6. 6 squared will give you 36, and that's what that constant term is. So again, you can factor this term into t plus 6 quantity squared, because when you FOIL these two terms out, you will end up with your perfect square trinomial. So anytime you come up with a quadratic equation that cannot be solved with using any of the methods we've learned before, we want to try and use this idea of a perfect square trinomial so that we can rewrite our original quadratic equation and then apply the square root property to try and solve these. So let's look at an example on how can we actually do that. So we have x squared plus 6x plus 7 equals 0. Now you can try and factor this term out and look for multiples of 7, which will try and give you 6, and see if you can factor that out into a perfect square trinomial. And we will not be able to solve this by factoring, so we need to rewrite this as a perfect square trinomial. So let's do that. Okay, so what we will do here is start with our expression x squared plus 6x plus 7 equals 0, and we will go ahead and move our 7 to the other side. Okay, we're rewriting it by taking the 7 over to the other side, and you end up with x squared plus 6x equals negative 7. Okay, now what we will do is try and make our left hand side a perfect square trinomial. Okay, for that all we need is our middle term. We're not interested in that constant term, and that's why we move it over to the other side. So now what we will do is take our middle term, which is our 6, okay, the coefficient of our middle term, and again, as I said, half it by 2 and then square it. So 6 divided by 2 gives you 3. 3 squared gives you 9. Okay, once you figure that term out, now what we are going to do is come back to our original equation, x squared plus 6x equals negative 7, and this time we are going to go ahead and add 9 on both sides. Now why do we need to add 9 on both sides? Because again, remember, this is an equation. You do not want to change the balance of an equation. Just like here, we subtracted 7 on both sides to maintain the balance. That's the same thing we're doing here. We're going to add 9 on both sides so that the balance of the equation stays the same. Now let's go ahead and see what happens. Your left hand side will be x squared plus 6x plus 9, okay, because of course you cannot add 9 into any one of these terms, and negative 7 plus 9 will give you 2. Now once we do this, we can go ahead and factor our left hand side. Okay, and this will factor out into x plus 3 squared equals 2. Okay, now you can see that this is the same thing that we had in section 1, where we could apply the square root property and try and solve these. So using the square root property, we can go ahead and set this up as x plus 3 equals square root of 2, or x plus 3 equals negative square root of 2. Now we know that you cannot simplify square root of 2 any further, so all you need to do is move the 3 over to the other side, and you end up with x equals negative 3 plus square root of 2, or again move your negative 3 over to the other side, and you end up with x equals negative 3 minus square root of 2. And these will be the solutions to your original equation, which was x squared plus 6x plus 7. And again, if you want, you can go back and check your answers. Just take negative 3 plus square root of 2 or negative 3 minus square root of 2 and plug it back into your x values in the original equation and see if you end up with a true statement. So now we can say that your solution set for this problem is going to be negative 3 plus square root of 2 and negative 3 minus square root of 2. Okay, and this process, this procedure is what we like to call as completing the square, because what we are trying to do here is on the left hand side we're trying to complete that square and make it a perfect square trinomial so that we can go ahead and factor it out into this squared term here. Okay, so this process, as I said, is what we like to call as completing the square. Okay, and what that really does is basically just changes the form of your equation, but it does not change the value of your equation. And to verify that, all you have to do is take this expression x plus 3 squared and go ahead and FOIL it. So let's see what happens when we try and FOIL that term. Now let's say we take this x plus 3 squared, which is the same thing as x plus 3 times x plus 3, and you have equal to, and let's see, let's go ahead and FOIL this, which will give us x squared plus 3x plus 3x, 3 3s are 9, equals 2. Combine your middle term, so that will give you 6x plus 9 equals 2, which is what we had right here at this point. Okay, and we want to try and see if we can come back to the original equation, and so we'll go ahead and subtract our 2 and bring it over to this side, and you will end up with x squared plus 6x plus 9 minus 2, which is 7, and 2 minus 2, which is 0. And let's see, x squared plus 6x plus 7 equals 0, and that's what your original problem was, x squared plus 6x plus 7 equals 0. So as I said, we're not changing the value of the equation, we're just changing the form of the equation so that we can write it in this form and then use the square root property to help us solve the equation.